We have been discussing about training, but what kind of training we should give? What will be there? So I would like to give some flavor of the training, what you can think about next 30 years. Okay? So just to get there here. And this is about some of the research work, what we are doing ongoing at Solin University. So the present research work, the IGNITE project, so I'm going to highlight some part of that. Okay, I think everybody is aware about the mass. We have spoken a lot of mass, but it's just for this slide, for those not that much aware of the mass, I just want to highlight one of the things is there about IMO has defined 4 degrees of mass. Just very quickly, once you go through that from here, degree 1, ship with automated process and this system here, but seafarers on board the ship. And the degree 2, remotely controlled ship with seafarers on board, but it has been remotely controlled from the shore. Then in the degree 3, remotely controlled ship without seafarer, but is controlling from the shore. And then degree 4 is a fully autonomous vessels. Ship will decide by itself, no seafarers on board. That will be the degree 4. So let's have that. This is one of the most exciting things going on about maritime industry, the growth of autonomous shipping. So we have got some prediction here. They said by 2030, also the Belal Ahmed has mentioned this morning about that. So we are talking about more than 554,000 seafarers needs to train. I'm talking about the officers. And also in these sectors will be about $11 billion by 2030. So we have seen there is intense competition going on between organizations to become the leader of the mass operation. As a result, incredible technological development can be seen in the field of autonomous system. I can highlight it about 4 areas, as you can see here. One of the things is about the technological development. Secondly, regulatory development, test bed for different trials, and collaborative environment. I'm not going to in details here, but once you know about what is about the training, how much we have done about the training, that is about the big question mark, especially in terms of the maritime education and training sector. So I just want to highlight a few things. It is not my research here. Different people have done research a different way to identify different challenges in the operation of the mass. Just to highlight some of the bullet points, as you can see there, one of the mentioned here, training and education are factors affecting the operation risks of mass. And also it has been mentioned about the training and reskilling is among the biggest obstacles of mass operation. Seafarers should know how to interact with the computer system to respond to challenges in the operation of autonomous ship. The important is to understand the new roles and skills that we require of human in the future. So is it MET is going with us in time? Again, some of the researchers said they are not doing enough to prepare that for the challenge that future may have. And also, researchers are saying that not much has been done in respect of MET, which has to be adjusted to the niche of the labor market based on the constant dialogue and close monitoring of the developing technology and the levels of different automation. One of the other points, also the researchers said, current STCW
convention, and code will not meet the development of mass. In the existing traditional MET curriculum, new knowledge of technology-related mass are not included, which will meet the niche of mass development. So it is making it urgent to reform in the MET. So you can see that one here. In the national, international level, some of the demonstration initiative has been taken out. I just want to give an example within the UK. In 2021, Maritime Coast Guard Agency has developed mass people with other partners like National Maritime Authority from Netherlands, Norway, Belgium, Denmark, France, New Zealand, Italy, and Poland, and also some of the industry. So the reason to work towards the development of international training standard for mass, this is really good steps what the MCA, Maritime Coast Guard Agency, has taken. And also another mass regularity working group in the UK, they have also formed in 2016 to identify issues related to the safe operation, to formulate a regulatory framework that could be adapted to the UK and other maritime nations. And also they are actually focusing three main areas: technology, standards, skill, and training. So that is about skill and training here. At Solin University, Warsaw Maritime Schools, what we have done already a couple of projects. One of the projects we have done, Maximus, Machine Executable Collision Regulation for Maritime Autonomous Surface Ship. So with the Rolls-Royce, we have done in our simulation center with other partners like Lloyd's Register, Atlas Shipping, Queen University Belfast. So that is actually one of the old projects we have done. I'm not going to details that one here. And another project with the sea traffic management, I think my friend Kistos is here, so we have been actually working. So that is about 4 years progress. With that also, we discussed about autonomy. And also in year 2021, in March last year, we have developed one of the new research center, that is the Warsaw Mass Research Center. I'm the foundation director for this research center. What the aim was there to conduct maritime research related to the advanced technology, education, training, and policy making for smart ship, smart sports, and mass. So we are presently on that research center. We are running a project called Intelligent Ship Center. So here, today, I want to give you a flavor, as I said to you. So this is an example of future maritime education and training, particularly navigational training. So we have been working with Wärtsilä for this project, and which project is finishing June this year. And then we will be talking about the next phase. So what we have done in that project, as you can see here, we have got a very unique capacity for our university. One of them is our ship handling center, a scale model ship, exactly the same characteristics of the ship, nothing different. We have been coming pilot from US, Canada, France, Australia, Brazil, and so many places they're coming from to get the pilot training. So exactly this is a scale model ship. And also we have got start out of the simulation center. That is one of the largest simulation center in the EU. So here we are connecting the simulation center and ship handling center together to see how remotely control can be done. So this is the actually remote control of an unmanned merchant ship for the future, and that is the Degree 3 for IMO, what they have been defined. So we have been using man model, as I said to you, and also full mission bridge simulator, and this center is about 10 miles apart. So we'll be controlling the man model ship from the 10-mile distance. Okay, what we have done, initially we have made a digital twins in our simulator. Exactly, we have replicated our ship handling center there, and also all the man model also has been replicated there, including with other, the fixed target, stop target, and all these features we have been there. So what we have done, we have then after that, once we made this one, we have done a validation. As this is the map of ship handling center, as you could see. We have actually run this testing around the lake with the buoy channel through the islands, north, south, east, west, everywhere. And then we have got the interaction between manned vessel and unmanned vessel. That means one of the ship has been converted to a scale model remote control vessel that has been actually competed with the other manned vessel also. And that manned vessel is being actually run by all the pilots and senior officers from the shore. And then here, we also has done, this is mainly focused on the pilot's area, especially pilot to berth or berth to pilot, and also interaction with the different ships. And also not only the interaction of the different ship, we have also the interaction of the fixed target, the stop target, H2 navigation, all sorts of things there here. So I'm going to demonstrate you here one of the video clip, what we have done, technical parts of that one here. So as you could see here, okay, and in the left-hand side top corner, that is the navigator one. So there he is actually navigating the ship from the simulator, where he has got real radar, ARPA, AIS, all sorts of, that equipments are there. What is normally used on board the ship, nothing different. Whereas navigator 2, my friend is sitting there, so he is controlling that one using the laptop and also the desktop simulator here. But he has been actually doing that one within the limit of the, with our ship handling center here, line of sight. And also our man model ship actually alongside of the berth. So let's see what's happening here. Okay, so this is the ship actually navigating from remotely from from Breeze simulator at our main campus, 10 miles from here. Another is in sight of line. So after that, what happened? We have done some analysis, the technical aspects of that kind of run. So as you could see that what we have achieved with our technical aspect of this demonstration here. We have developed a technical test bed to make the training and experiment of the newly skilled seafarer to command and control remote and autonomous ship. And also this actually enables us to control the dedicated scale ship model from multiple types of control, including laptop, desktop, and full mission Breeze simulator. But however, we have found that providing situation and spatial awareness with the use of the digital twin in the simulator is more effective training And because here we have used all these sorts of cameras, also RTK position sensor, which can give you about within 1 meter, 1 centimeter accuracy. Then also it provided real-time monitoring of manned traffic vessel as well, introducing the virtual vessels and obstacles in the training scenarios, utilizing real ship instrument like a GPS, radar, ACDIS, AIS, and control, as I said before, and that has been done from simulation center. So we also had ability to introduce technical faults, malfunctioning of the equipment, different weather condition, and also the ship control. So this is about the technical aspect of the project. Now we are thinking to go for the next phase project that is about, we'll be concentrating about the training aspect. So on the basis of these 3 questions are there, what we thought is very most appropriate, that one. So we need to find out how the skill set will need to change, and also what skill we'll need to taught as we move forward, and whether this task can be done within a team or someone is controlling from laptop or desktop. What do you think? So that kind of thing we want to prove in the next phase. So we have looking for some funding now, and hopefully we'll be starting the project very soon. So what we have done in that project, second phase project, we'll be developing a training structure of the remote operation, including remote pilotage in degree 2 and degree 3 autonomy. Here we'll investigate to develop hard and soft skill required for the remote operator or navigators. Also, secondly, we are looking for remote control navigators, teamwork between remote operator and ship crew in a degree 2. If you remember, degree 2 means seafarer is still on board the ship. In that case, also remote control navigators will carry out remote monitoring and troubleshooting, and also different handling situation, emergencies, that kind of thing. Thirdly, as a result of mass implementation, the training that needs to be undertaken will also change. In the scope of Project Ignite, we'll be looking to deliver the possible solution in the area of developing skills and the navigators of the conventional ships to safely operate in waters cohabiting with mass. That means the interaction with because not only remote control vessels, we have to also understand when there will be interaction between transition stage. Fourthly, there will be a researching and development of human element aspects of remote operator. So any provision of skill of human-machine interaction will be required to operate uncrewed vessel or unmanned vessels. Fifthly, we need to further develop the safe test bed facility to our ship handling center for the testing the future autonomous technology for mass, as well as carrying out mass training. As you may be aware that at Solinville University has got a unique facility. We had to get the facility that we can actually apply that facility. In this case, in the test bed, also we can do, that in the different phase, especially when we'll be starting partially automation, then gradually we'll be coming to the fully autonomy. So in the different stage of the autonomy, how this training can be carried out, that is also we'll be investigating that one here. Finally, we will explore to support development of the future curriculum, especially we'd like to give advice to the IMO for the future model course, IMO model course for the future operation and the future for the navigators here. And also you have to remember that in the technical aspects, especially even then, how the latency can contribute in the, especially when you are remotely controlling from the shore.
it is not a video game or anything, because that could be a disaster in the future. That kind of thing also we like to investigate how much delay can occur an accident, so that it can be actually find out a solution and also the special situation. So thank you very much. I hope that you got some flavor now. So if you have got any questions, I'll be happy to answer.
Great. Thank you very much, Professor Boyan.